Awesome. Okay, well then I will start with this. Again, I'll start recording it. It will get posted onto, I'll put it on Google Classroom, but you'll also be able to have it'll like be on YouTube as well. It's kind of the easiest place for me to put it. Okay, so the stuff we're gonna do today, 7.5 factoring linear equations. Okay, so the stuff we'll do is first objective, and we're going to find the greatest common factor of two monomials. A monomial is going to be one number letter combination. So like 24, 36, 5x, 25x. Okay, that's kind of what a monomial is. It's going to be like that one number letter combination. Okay, and then we're going to use properties to factor linear expressions, meaning we're going to have two of those. We'll have like a monomial plus another monomial. So we'll have kind of like two groups of numbers and letters together. So let me zoom in just a smidge. All right, so you said we have done this one before, the factoring. Who remembers the factoring? Give me a thumbs up if you have. Give me a thumbs down if you do not remember doing factoring. Okay, I got some in the middle, some down. Okay, that is perfectly fine. So I'm going to kind of start off when we do this first one. I'm going to explain what the factoring is and then how to get to the greatest common factors. So when we look at factoring, or what factoring is, we can break down numbers into kind of bigger groups. And I'll start with this number 12. Okay? So with number 12, and I'm only going to look at 12 right now. To get 12, I'm going to look at some different combinations of numbers that I could multiply together to get 12. Okay? So I could multiply 1 times 12. That's a factor. I could multiply 2 times 6, because 2 times 6 is going to equal 12. I could multiply 3 times 4. And if I wanted to get really crazy, I could multiply 2 times 2 times 3. Because 2 times 2 is 4, and then 4 times 3 is going to be 12. These are all different ways that I can factor it. But I'm going to show you kind of a little quicker way, a little easier way that we're going to do it. We're also going to use some exponents, okay? So first thing we're going to do is we're going to look for prime numbers. Who remembers what a prime number is? Nobody? It's kind of like that. So a prime number is going to be a number that is usually only divisible by itself and the number 1. And we just started this. We went over the test prior to this. So we just started it. This is the very first example. I'm going to kind of zoom out for Alex real quick. The stuff we're doing today is going to be finding greatest common factor. And that's kind of how this stuff's going to work together. Okay, so with 12, what I'm going to do, and this is kind of like when we were figuring out fractions. We're trying to simplify fractions. This is a little bit like that. We're just kind of working in reverse. So these were all the different factors that we could have for 12. What I'm going to do is I'm going to start working through and try to find every single prime number that I can divide 12 by. So with 12, let me get a different color here. Oh, Mr. Word, you weren't in here. Also, I've now got the microphone. We're going to post the videos onto like Google Classroom and like YouTube. So that way, if they want to rewatch it again, then they can go through that. So if there's something that gets added, remind me to make sure I can say it loud enough so that way they can rehear it again on the microphone. I'm channeling my inner YouTube star with the microphone here. Okay, so with 12, I'm going to look at all my exact prime numbers. So if I've got 12, I know that I can divide this one by 2. Okay, so my first one, I got it divided by 2. So I've got 2 and 6. Those are my first two factors. I know that this one, here, you know what? I'm gonna do the tree style. Yeah, sorry about that. So I've got a 12. I'm gonna make a tree. I can divide it by 2, and then the other number is 6. So what I'm doing is I'm just getting every single factor. So far, 2 times 6 is 12. This one's prime. This one I can't go any farther on. But the 6 is still even. I know there's more I can do with it. I can break down 6 into 2 and 3. Okay, so all the factors that are part of 12 are going to be all these ones at the very bottom of the tree.
Sometimes I even like to bring down the 2.
Yep.
So it's like
just straight down, so it's in a row. So if you want to leave it as the tree and just kind of have them all in the exact same line, you can do that. If you like to see them kind of side by side, I'll usually do like this one, and I'll just put 2, 2, and 3. I'll just put them all in an order like that. So here's all my prime factors. Again, the prime meaning that they can't be divided again, of 12. I've got a 2, I've got a 2, and I've got a 3. If I were to multiply them all together, that's what I get for 12. Let me get another color. And I'm going to do the same thing with this 28C. So I've got 28, and I've got a C. I'm going to start breaking this stuff apart. 28 can get broken down into a 2, a 14. I'm going to give it one extra branch over here because I've got a letter. This C. The letter C is part of this, so I can't forget about it. Okay, this 2 is done. I'm not going to do anything with it. I'm going to keep on bringing it down. 14, I can break apart into 2 spots. That's a 2. That's a 7. That's still a C. Is 2 a prime number? That's as far as I can go. This one's done. Is this one done? This 2's done, yeah. Is this 7 done? That's a prime number, can't go any farther. Is C done? Perfect. Okay, so I've got 2, 2, and a 7 here. Here is where I can do that, or I'm going to put it over here so I can say 2, 2, 7. And a C. Again, every single one I have to write. Even if I have 2 of them in a row, I need to write both of those numbers. Okay, I'm going to grab a highlighter. Actually, I'm going to make this row go down an extra couple spots so you can see it better. What I want to do is I want to see the ones that they both have in common. So this one has a 2 and this one has a 2. They've got another 2 and another 2. Do they have anything else in common that I haven't highlighted yet? This one has a 3. Does this one have a 3? No. This one has a 7. Does that one have a 7? No. This one has a C. Does that one have a C? That's as far as we can go. So all the stuff that I highlighted in blue is going to be the stuff that they have in common. So again, I'm going to go like an extra step that you won't normally have to go, but I want to show you what I'm doing. So I've got 2 times 2. They both have that in common. If they both have it in common, it's going to stay on the outside of these parentheses. The next thing I'm going to do is I'm going to look at the stuff that's left off. Okay, on that first one, that number 12, they had a 3 left over. I'm just going to put it right there in the parentheses. And then I'm going to have a plus sign here. So I'm going to have two separate things. Okay? Actually, I'm going ahead to the next lesson, or next part of it, but I apologize. I've got a 7 and I've got a C. They don't have any matches. This one's going to go here for the 7. So I've got plus 7 times the C. That's going to go down there. So the very last part, I'm going to look and see what they have in common. So this one that they have in common, 2 times 2 is 4. I've got 3 plus 7 times C is 7C. When I factor those two monomials, the thing they had in common, the greatest common factor, was this 4 over here. The stuff that didn't fit in, that wasn't part of it, was this stuff over here. Okay, that's the stuff that doesn't go nice and perfectly into that same container, and that's why it stayed over by the side. Let me zoom out I think I'm combining two parts of my problems. I sure am. So for right now, that's going to be a little bit of what we do for the first part and the second part. I'm not going to erase it. This stuff's still super important. But I'm going to go just the very, very basics for the next couple. So I got a little too in-depth for that first one. I apologize. I've been away for too long. God bless you. Good. Okay, I'm going to go down to this next one. We're going to do that same tree. Sorry, on the G more time. You good? Okay. I'm going to do the same thing. We're going to do that tree thing. But I'm going to do that with both of them. I'm not going to do the parenthesis things at the end. We'll do that for the second part. We're just going to factor them right now. So I've got 25x. I've got a 2, 5, and an x. I'm going to start off and I'm going to make some trees here. Also, if I've got letters, I'm going to make an extra part of that tree. 25, I'm going to try to figure out what I can divide it by that's going to be prime number. I know 25 can be divided by 5. If I use my calculator, I can do 25 divided by 5. That tells me this other one is 5. And then I've got an x. That's getting brought down. Can this get broken down anymore? Can this get broken down anymore? Can this one get broken down anymore? Perfect. That one is at prime factorization level. I'm going to grab a different color pen. Now I've got 15x, y. I've got 2 letters. This is getting crazy. Okay. I'll start with my 15. Perfect. I got 3 times 5. This x is all by itself. This y is all by itself. So if I was going to look at it and I wanted to put kind of commas in between it or multiply it all together, this one is now at the prime factorization. I've got a 3 times 5 times x times y. That'll give me this. Here is where I'm going to look at it, and I'm going to try to make sure that I see what they both have in common. So I'll start with this first one. This one has a 5. This one has a 5. Perfect. They both have a 5 in common. Okay, it has another 5. Does the other one have a second 5? No, I'm done. This one has an x. Does the other one have an x? Ooh, they both do. Sweet. I'm done. If I get to the end of this first one, I don't need to look at this because I can already tell that if it didn't have it the first time, it's not going to have these ones either. So I'm going to look at the things that I circled, and only the things that I circled in one of the sets. Yes, I circled it in both, but if we did both of them, it wouldn't work out. So I have a 5. I have an x. So it's 5 times x. The factor they have in common is going to be 5x. Does that make sense on what I did? Yep. Sweet. Okay, I've got 42 and 14. I'm going to grab two different color pens again. We're going to do it the same way. 42 MN. I'm going to start just with this number here. 42, I know I can divide that into 2, and that's a 21. Then I got an M, then I got an N. 2 isn't changing at all, staying the same. 21 can get broken down, though, into a 3, and then a 7, M, N. Can I do anything else? No. Done. We're done with it. We're not going to touch it again for a while. I got this 14, M, N. I forgot what I'm doing. Someone help me out. What am I going to do first? Okay, I'm going to break down the 14. 14 will turn into 2 times 7. Can I do anything with this M? Just bring it down. Yeah, perfect. Anything with the end? Bring it down. Can I break up those numbers anymore? No. I'm at prime factorization. This one's good. This one's good. Now I need to see what they have in common. All right. First number I'm going to look at, I'm going to start on the very first group of numbers. This one has a 2. Does the other one have a 2? Yes. Awesome. Again, circle it, underline it, or rewrite it down. I'm letting you know right now the things that will be beneficial, that will help you succeed. Either circle it, put an underline under both of them, or write it in a new spot. Those are going to be the 3 things that you'll need to do to make you successful in this one. Okay, this one has a 3. Does the other one have a 3? No. Do I do anything with it? Ignore it. This one has a 7. Does the other one have a 7? Perfect. 7 and a 7. This one has an M. Does the other one? Perfect. This one has an N. Does this one have the other one have an N? Yep, they both do. Okay, I'm going to look at the stuff that they both have in common, and I'm going to write it out as if it were a multiplication problem first. I'm letting you know that I write it out with every single one of these things, and then I will combine the terms. So I've got a 2. I've got a 7. I've got an M. I've got an N. I'm going to put all that stuff together. 2 times 7 is 14. M, N. That's my final answer. So far on a scale of 1 to 5, where are you guys feeling with this stuff? I like it.
And to even go further, if you wanted to, if you want stuff where it's even, you could put the 42, you could put the factors, beside it, 2, 3, 7, and then underneath you could put the 14.
Okay, yep.
Because some people, if they want, so then they can compare top and bottom to the side to side. But
Oh, yeah, I get what you're saying. Okay, judging by the amount of 5s that I saw, show me that you can factor this. I got 48x, and I have 28x. Factor that on your paper, and I want to find the greatest common factor for both of them. this one, tap this one, tap this one to get to the final answer.
Still gotta break down. This one, because 2, 4 is not prime.
Yeah.
2 2s though. 4 breaks down to 2 2s.
So we need to go from this number and this number. We need to bring it all the way down to all the prime numbers.
Okay. So whatever they have in common, just circle the ones they have in common. No. Just.
Yep, so far
There's only one set of 2s, there's not another set of 2s over here, is it? There's a set here. There's a 2 here, 2 here. What do you get? 2 here. So that's it, you don't circle the other one, it's 4. So, how much of the 2 times 2 max? So what's your? So you're right. Here's another small. Break down every single one. It's 2 that's right here. So it's going to take a little while. If you're not quite sure, I'll show you what I do. I still have the first part.
I just got to edit. Mine was justifiable. I saw it was 28 24.
My guy.
I can go to the
So much. It's 2.
What do you guys want?
There you go.
Yeah, you're you just choose.
Then stay here. Yes. Hey, Danny, David Claire.
34.
What time is 30?
11.
Alright.
So that's 7 as far as we go.
Wait,
Yeah, there. So we're there. So this is row 4, 7. So this 2.
I was still in the library.
This 2.
Joyce in second period.
I have Jones second period.
Just make sure they're all
going to be there till Thursday.
Probably.
Last Thursday.
2
Yeah,
to
Friday.
2, 7.
Whoa.
Bro, we were there till Friday.
I'll ask
Last Friday.
I'll ask Brady.
Yeah, so we're saying we're struggling.
Huh?
And both of the numbers all have count.
Brady.
So, right. So each time you see one that's in common, circle it's full.
Well, how was that from that guy? Students the other way.
All the things that you circle, just this one. Just the, yes, just the circle.
He's saying.
I like terms with that.
Would be.
College right there.
Like a whole whiteboard on here.
What?
I'm gonna do this one. Right off the spot. You have space to look at it. Yes, sir.
Talk about what math classes we're taking.
The one you'll take next year should be Algebra 1. Yep. So the class right after pre-algebra is Algebra 1, and then the following year will be Geometry. Then if you want to take it again, which would be, that last year will be Algebra 2.
Isn't there, what's the other math called? It's like algebra. It goes faster.
Yeah. They have advanced.
Oh, that's modern.
Yeah, modern algebra. Okay. For those people who were still working it, I'm going to write these ones down. I'm going to show you the steps that we did. So this 48x, and as you guys found out, there was a lot of steps to this one. This one would have turned into a 2 and then a 24. I'm going to bring this 2 down still. 24 gets broken down into 2 and 12. Bring it down. Bring it down. This one goes into a 2 and a 6. Bring it down. Bring it down. Bring it down. So it gets broken down into 2 and then a 3. This x was all by itself, and I just kind of left it over there for right now, and I brought it there. Okay, different color. 28x look like this. 2 and then 14. This one gets brought down again. This one gets broken apart. This is a 2. This is a 7. Okay, I'm as far as I can go. I'm going to bring this x over with me, just so that way I can have them about the same location. I'm just going to bring them straight down. I've got a 2, I've got a 2, I've got a 7, I've got an x. Instead of grabbing a highlighter, I'm just going to circle them with a different color pen. This one has a 2, and this one has a 2. This one has a 2, this one has a 2. All my 2s are used up on the other one. There's no 3s. This one has an x. This one has an x. The stuff they have in common is a 2 times another 2 times the x. Only the things that are circled. And only in one of them. So this is a 2, the 2, the x. So 2 times 2 times x is 4x. That is my answer for that one. Okay?
And again, it doesn't matter, like, if I wanted to choose for 48, if I want to choose 6 and 8, it's still gonna come out the same at the end, okay?
Oh, yeah, let me tell you what. Let me move this thing over and I will show you exactly what Mr. Rourke's saying right there. Let's see if I'm good enough at all this. Get out of here. That was awesome. All right. Sorry, I'm easily excited. So what Mr. Rourke was trying to say was, if we had that 48 and an x, instead of doing the 2 each time, if I decided to do 6 and then an 8, and this would get broken down into a 2 and a 3. This one would get broken down into a 2 and a 4. This one's done. This one's done. This one's done. 2, a 2. I still have an x right there. I'm just going to put them in order from the smallest to the greatest, just so I can do it. So this 2 will go here. This one will go here. This one will go here. This one will go here. My 3 will just put in numerical order there. And there's my x. They both have a 2, 2, 2, 2, 3, and an x. This thing and this thing are the exact same set of numbers. So no matter which way you break it down, either going by the prime numbers or any multiple of the big number on the top, you will still end up with the exact same prime factorization. Okay? This one, I'll kind of do it with you. Or actually, you guys are going to talk me through this one. I need one person, one brave soul, to tell me how you would factor that 16s. Hector, what do we got, buddy?
4 and 4.
Okay, so I've got 16s. Hector's going to go 4 and 4. You're going to talk me through the whole thing. Keep going.
You simplify farther than 2, 2, 2, and 2.
2, 2. 2 and 2.
You bring down the S.
Perfect. That one's done. I love it. Okay, another brave soul. I want you to factor that 40 ST. Austin, what do we got, buddy?
5 times 8.
Okay. We got 5 and an 8.
For the 8, you can distribute it to like 2 times 4.
Okay. 2 and a 4.
And then the 4, you do 2 times 2.
Perfect.
And then you bring down the S and T.
Perfect. Okay, next brave soul. What do I do next? I know you two got it. You've been talking me through it. Luis? So circle the 2. I'm just going to go step by step just so I can have it. So I had 2 on both sides, and then you said circle the 5. Okay?
Yeah.
Oh, yeah, that is an S. Just kidding. See, my S is in. That's why I usually choose different letters. Okay. So I've got a 2. Which one did you say, Luis? The S's. S and an S. Sorry about that. Okay. They don't have anything else in common?
Oh.
So far I've got these 2. Do they have any other ones that are still in common? The other 2s. So again, yeah, you have the 2s. What I'm going to do is every time I circle one of the 2s, I do it to both of them because math is fair. So I did a 2 over here, a 2 over here. There's still more 2s there. I got a 2 here, and I got a 2 here. How many? Remember, I only need to look at one of them. I can look at this guy. I can look at that guy. These are my eyes, just telling you who to look at. Or I can look over here. I can look over there. Let me make my eyes better so they're looking up to that side. I can look over there, or I can look over there. But I can't look at both spots, so my eyes get all wonky. Okay, so which one do you want to look at? But I can't look at both of them at once. Left side, this guy? Okay, awesome. I'll just look at the left side. Okay, somebody new, because Luis talked me through how to put those ones together. Somebody brand new. He said to look at the left side. What am I going to multiply together? I watched the work. You guys had it. Daniel?
You want me to tell what you
Yeah.
2 times 2 times 2 times 5.
Or S. Yeah.
Oh, it's
It's an S. My handwriting. It's on me. It's on me. So now I'm going to have the 2 times 2 times 2. 2 times 2 times 2 is an 8. And then this last one is an S. That's my final answer. That's the stuff they have in common, is an 8S. Okay? If I did these ones, I'd still have 2 times 2 times 2 times the S. So I still would have had 8S. Again, I can only look at one side. I don't look at both of them. All right. So the factored form, this is the one that I started with at the very top. I got ahead of myself. And and I apologize for that one. I confused you to start with. So this one is going to go the exact same way. Exact same way that we factored the other ones. It's just that all that leftover stuff we get put back together. So 4x, I'm still going to factor that. That's still going to factor down to a 2 and a 2 and an x. Oops. This other guy, this 28, I'm going to factor that one down. Mainly just because you mentioned it before, so I'm going to do it with a bigger number. So I got 4 and a 7. This one still can get factored down to a 2 and a 2 and a 7. Okay, in between it, here's what I'm going to do. In between it, there is a plus sign. I'm just going to kind of make that plus sign because that's showing me what was there at the time. I'm going to look at what they have in common. This one has a 2, this one has a 2. This has a 2, this has a 2, and that's it. If they have this stuff in common, that stays on the outside of the parentheses. Whatever was left off, come on, there you go. Whatever was left off, like this one and then this one, that'll be x plus, and then whatever was left on that other side. So x plus 7. And the very last thing I'm going to do is I'm going to multiply the stuff they have in common. So that 2 times 2 turns into a 4. And I've got an x plus 7. If we did the stuff from lesson 2 and I distributed it to both of those, what's 4 times x? 4x. Oh my gosh. What's 4 times 7? 28. Even better. Math is magical. Okay? So you can double check by doing the distribution at the end of it. But yeah, we factored that perfectly. All right, this 3 plus 33x. Somebody talk me through what I'm going to do. Austin, first step.
You're right. 3.
Okay?
And then bring it down because it can't be.
And that's it. That was like the best one to choose ever. That was the easiest one. I like it. Okay? There was a plus sign. Just like the Super Bowl halftime show and Dre. We can't forget about it. Okay? So we got that plus sign there. Next one I'm going to choose is going to be that other side. So I've got 33x. Somebody new. Daniel.
3 and 11.
Awesome.
Bring down the x.
So great. 3, 11, and x. Can we do anything else for factors? We cannot. You are stellar. You're perfect. Okay. Now we're going to see what they have in common. Somebody new? What do they have in common? Luis?
3.
They both have a 3. This one has a 3. This one has a 3. Can I circle anything else? No. That 3 stays on the outside. Is there anything else left on this side? No. If you can't see it, what are we going to give it? An imaginary?
1.
Imaginary 1. I love it. So I got 1 plus, because I can't forget about this plus sign. What was left over that we didn't circle in that the one on the right? 11x. I'm done. That's it, guys. If I wanted to double check it, I can distribute it. 3 times 1 is? Oh my gosh. 3 times 11x is? Even better. You guys got it. How you feel on that?
Thanks.
Little. I'm going to give you guys one that I want you to show me that you can do. That'll be homework time. Okay. I've got 4x plus 35. Just tell me when you guys get done factoring. Don't worry about anything else, just the factoring stuff.
So we don't do those.
Yeah, you can, but I mainly want to make sure you get done with the factoring part. That's what I want to look at. This one needs to be one of the branches. That was 2, 2, and then a 1. So this is 4 right here. should have a branch on it. So it should be, yeah, 2, x. You just need to add 1 x, or 1 more 2. Okay, then just don't. Perfect, you got it. All good? Okay. Do they have anything in common?
No.
Nothing. You guys factor that thing so quick. It was awesome to see how quick you guys got these ones down. You had this one down. This was a 2, and an x. This was a plus sign. That 35 got broken down into a 5 and a 7. You told me immediately they have nothing in common. If they have nothing in common and you want to write it there, it's just 4x plus 35. You can just write it as 4x plus 35, or you can put it with a 1 on the outside. This and this are the exact same thing. So again, if there is nothing in common, you just rewrite the problem. That's it. Okay? I'll put those notes on there for you. But the stuff you guys have for your assignment that's due on Wednesday is going to be page 319, 22 through 38 even. The first chunk is just telling me what they have, what the factor is together. The second chunk is going to be that stuff where you're going to be factoring it and then having the parentheses where you're adding the stuff together. Okay, we've got about 6 minutes left, 5 minutes left of class. You guys can get started on that. I will work on posting this to YouTube and saving the notes.